So we'll go ahead and just welcome Roger one more time for the recording. Welcome, Roger. Thanks.
Okay, thank you so much. And even though you pressed the record button, I'm not pulling out another speech because now I'm being recorded, so don't worry about that. Yes, as already stated, I am a member of AGU. I'm a geoscientist, and I believe I'm the only geoscientist of all of the vice chancellors for research within the University of California system. So I believe I was just going to provide my own perspective, which I have been involved quite a bit with open science. It goes without saying that I'm very strongly supportive about open science. And I'm going to say some things that I'm sure are quite familiar with this group. First off, there are two components of open science. One is one that I think is much more tractable. And in fact, we've made huge progress on, and that's publications. I think the more difficult problem, not that we can't surmount the difficulties, is with data. I think that's another whole different problem, not as simple as publications. I'm a member of the National Academy Roundtable on Open Science. And one of the things that I've always taken back home with me was the triangle that we talk about on that roundtable. One point is research values, such as transparency, replicability, and sharing knowledge. Another point of the triangle is best practices, which I think is obvious. And the third, one that I think is really key to the success, especially for data, is incentives. And by incentives, we're talking about privilege and tenure, we're talking about funding, we're talking about citing open data. And we still have an uphill battle for universities to ensure that researchers receive credit, for example, with P&T, because if you don't, then it's always going to be difficult to get faculty and researchers to buy on to open science. Other things I'd like to say is, again, COVID-19 was the poster child for why open data and open publications are so critical, but it's not the only example. Just to cite a couple others that, again, I'm sure some of you are familiar with. NASA's citizen science, essentially throwing the data out to the community, has led to the public discovery of planets and comets. Let me cite NOAA, the National Oceanic Atmospheric Administration. By throwing data out in the public, essentially having an open data policy, this has led to a business argument because we now have over an $8 billion private weather industry. You know a couple of the companies, I believe, the Weather Channel and AccuWeather. But they wouldn't exist if NOAA had not said that we're going to just share our data with the community. But we do have challenges, and let me give you one example from my time at the National Science Foundation. As you know, NSF supports some just huge infrastructure projects. Some in the geosciences include the Critical Zone Observatories, NEON, the National Ecological Observing Network, ALTER, the Long-Term Ecological Research Network, OOI, the Oceans Observatory Initiative, all supported by one agency, all with open data policies. But I can tell you right now, I cannot on my screen bring all those data sets together to plot them in one integrated way, which one would hope that is one of the goals of open data. So even if one agency is strongly supporting open data and is supporting all these facilities, you can see there's still challenges, not non-trivial challenges that we need to overcome. Software is one that I've thought about a lot. One example is while I was director of NCAR, the National Center for Atmospheric Research, we had NCL, the NCAR command language. It's simply an open software that allows you to analyze and visualize largely, we thought, geosciences data, immensely popular in the community. But this is an example of what happens when you allow data to be open software. I couldn't have guessed that, I'll give you just two of many examples, that they'd use the data to plot snake bites in Brazil. Another example is insurance companies have used it. They find it very effective platform to plot data. These are examples that we couldn't have guessed to begin with, but by allowing it to be out there in the community, people can use it once they find out that it's discoverable. I think with data, we still have some discussion about what do we mean by data. Is it the raw data? Is it the edited data? Is it data products? I can tell you that in my own discipline, if I just threw the raw data out there and made it open, not everyone could use that data. So you have to ask, well, what use of it if I'm putting data products out there that not everyone can easily use and interpret? Another example about software is I'm very familiar with community climate modeling. Here we're talking about millions of lines of code. A lot of it's in Fortran. And of course, when I go to the computer science department and say Fortran, they're telling me I'm from the prehistoric ages. What is our requirement to try to save that code and make sure it's operable on the new generation of platforms? You can't save all the output on a lot of climate simulations. We're talking about tens of thousands of years of a simulation. It's not physically realistic to save all the output. So what output do we save? And if we do save the code, again, as I said, what is our obligation to make sure it's can be rerun? In fact, some people believe that even if you could run it on the new platforms, you're going to get a different answer. That's just the way it goes with these kinds of model simulations. One thing that maybe is slightly controversial, but I do believe is something we need to talk about. I think the majority of data absolutely needs to be saved in perpetuity, but I'm not convinced that all data needs to be saved, especially, for example, a single PI doing a very small project that may be supported for just 2 or 3 years and the grant expires. I think there's some obligation to save that data, but I think there's a time limit on that. And I think even some of the Science Foundation program officers are starting to come to that realization because data is increasing exponentially, even as I talk. And so, although I think there are certain data sets that absolutely have to stand the test of time, it isn't clear to me that every single data set has to be saved. By the way, one example of something that has to be saved forever, I'll just throw one out there, LIGO. Observations of the conformation of gravitational waves, that must be saved and must be saved forever. Of course, I think I'm speaking to the choir that one starting point that I hope that everyone across the board achieves is that research data and software that underlies scholarly publication is a no-brainer. I think we must achieve that across the board, and to do so would be just an enormous win. I can envision agencies requiring data to be part of publications, working with scholarly societies to make sure it's essentially a requirement. In terms of some of the things I can do, just to let you know, when since I'm the Vice Chancellor of Research, these are things that I hope my counterparts do. I just met with all new faculty coming on board. And in fact, in that orientation, I actually talked about open science, open publication, and open data. I think that responsible conduct of research discussions, which I'm involved with, should talk about open data especially. And a very easy win that I'm surprised that more people aren't thinking about. There's been sort of this wave across universities about data science initiatives or data science institutions. Many of, we're doing it here at UCLA. I know Berkeley's done it. I know a lot of universities across the country are doing it. It is so simple when they talk about curriculum development to make sure that open data is part of that discussion. And I know in a lot of data science initiatives that I've talked to, the people that are leading those efforts, they actually said, oh, good idea. So they actually weren't thinking about including open data and replicability and reproducibility as highlighted in their curriculum development. So I've been sort of beating that drum, which I think is an easy one. That's low-hanging fruit. So I hope I was a little thought-provocative and provided some background into some of the things I've been thinking about. And I'll just turn it back over to the organizers. Thank you very much.
Thank you, Roger. And next up, Brooks Hansen, who is, as Todd said earlier, the Executive Vice President for Science for the AGU. We'll talk about best practices with AGU and journals.
Oops, thank you. So thanks, Roger. Thanks, Tim and Todd, and thanks for organizing this. It's great to follow Roger, and I'm going to build off a lot of what he has said. I'd like to take a high-level framework and be a little provocative on how the key stakeholders can and should work together for open shared data, and really the imperative for that. And I'll frame that a little bit in terms of, I realize that the focus of this is on open data, software, samples, et cetera, but really frame it in terms of a broader perspective of open science. And let me say also, it is fantastic to be back at UCLA, even virtually. I wish I was there in person. It really was the foundation for my career. After UCLA, I did a postdoc at the Smithsonian and then went on to work at Science Magazine as an earth science and then physical science editor for quite a while before moving to AGU. So it really, having the really diverse set of connections and input and thinking that at UCLA really started my career. So it's great to be back. And let's see if I can go to the next slide. Okay, cool. So let me frame this as an imperative. This discussion has been going on for quite a while on open data and open science. And I think we're at a point where, one, it's very exciting, where I think we have the pieces to actually implement what we're talking about or dreaming about or imagining right now. But at the same time, there's, as Roger said, there's still some significant cultural and institutional barriers to this, but we can overcome them. And let me just really emphasize that I think it's critically important that we do that, and do that rapidly and soon and thoughtfully. There's many key challenges for the 21st century. The last year and a half have kind of helped focus them a little bit. But we have one habitable planet, and all of the major sustainable issues are core to convergent and transdisciplinary science. Here's just some of them. There's more. Obviously, we have to feed 7 billion, soon to be 10 billion people. The major health issues are convergent. We've seen that in the last couple of years, but some of the largest health issues are related to air and water and soil pollution. Those are also connected to a whole variety of biomedical issues. All ecosystems and biogeochemical cycles are now human dominated on Earth. We have a huge climate change experiment underway and an imminent energy transition to manage as a result of that. Key limited resources that we have to manage for the future. The entire economy is based on science. And I'll talk about that just Roger gave a couple examples, I'll give a couple more. And obviously natural hazards, weather, and climate forecasting are also critically dependent on this interdisciplinary science. It's engineering, science, and multiple sciences. And a lot of our science structure, both at the university and in societies, is not really well set up for this convergence. And to build the trust with society, these require data and integration with modeling, as Roger mentioned, but also open science with integrity is a must to build that trust with society worldwide, who has to help implement some of these decisions. So the focus is on data, and I'll just mention that actually AGU's data position statement was adopted in 1997 and has recently been updated. But it mentions that Earth and space science data are World Heritage, and this applies to a variety of others, ecological and other data as well. And this is because, in essentially, Earth and space science is inherently irreproducible science. You have an earthquake once; it's never going to be the same earthquake again. You cannot go back and redo that experiment. The entire Earth is evolving, and we need long-term data to understand that evolution. And it's not repeatable. And the other thing that's nice about this statement is it recognizes that a variety of stakeholders, researchers, repositories, publishers, funders, institutions, et cetera, really need to work together to solve this. And that'll be the theme throughout this talk. So just to highlight also and amplify a couple of other things that Roger said, we should already, we've already seen an enormous benefit from open, shared, interoperable data. One, Roger mentioned weather prediction, which is essentially about the improvements have been about half data integration and about half modeling. And that data integration is worldwide. So we now know that, dust data from the Sahara will influence rainfall in California in a couple of weeks. And we can predict that and incorporate that data and modeling into that forecast. And that has somewhere estimated of $1 trillion a year benefits to the world. The GPS system is another system that relies on interoperable data on Earth's gravitational field, magnetic field, solar activity, and atmospheric dynamics to make the GPS system work, which is estimated at about $1 billion a day benefit to the US, or about, so $300 billion just to the US per year, over $1 trillion of benefit to the world. We have to celebrate that, and those are some great examples. So as I mentioned, I'm going to put this in the context of a larger framework on open science. So when we think about open science and open data, we often think about the first bullet here, open content, meetings, publications, data, software, samples, methods, so forth. So just under under these bullets are a couple efforts that AGU is involved in black, smaller type, just to emphasize that I think we're trying to move forward on all of these bullets, and I don't have time to go into these, but happy to talk further about them in the questions and answers or offline. So obviously we think about open science as this content, but there's a broader integrated effort that's needed and that we need to think about. One is supporting broad communication and outreach to the public. In addition to that, we can't just talk at the public or to the public. We have to engage with them and help communities in particular solve, access science, understand it, and solve some of their problems, especially disadvantaged ones, because those are most impacted by the sustainability issues that were in the first slide. And we also, as related to that, to build that trust and integrity, we also, and improve the perspectives on science, we need to expand diversity and inclusivity in science and address bias and harassment that discourages people from scientific careers and from applying science. And all of these work in concert together. All of these are a part of open science, and we need to support all of them. And that means that we need a scholarly culture that supports and reinforces these. And I think, as Roger had mentioned, there's some efforts on this, but we really need to address this soon. And I'll talk a little bit more about that as well. So here are 4 challenges and 4 kind of that organized by stakeholders for addressing these. These are not all of the things that need to be done, but I think if we could address these, we'd go a long way to making, really taking some large steps to organize the culture of science for those challenges that we need to face. And actually what I think is all of them, the solutions are there, and we just need the will to do this. So one is, which I think will be the focus of a lot of what we hear about today, is publishers and repositories need to work together to solve open data and software citations, and so that data are not just included in a supplemented paper, but in a way that is findable, accessible, interoperable, and hopefully reproducible and reusable. You can ignore the diagram on the left, which is just the infrastructure that allows this. And we know what we need to do. Repositories, data need to go into repositories supported by permanent identifiers. Publishers need to, and researchers need to cite those. And then we need to get the rest of the system to work. And that would greatly increase findability and quality in data. The second thing is funders need to help by really emphasizing the importance of data software in grants and awards. And if you look across most of the major funders now in their instructions, both to authors and reviewers, and I've put 4 that I've looked at pretty closely, they really focus still on intellectual merit. They all have data management plans, but these are often the last things in grants and are not elevated to the way that really science is done today. So for a possible better way would be an outcomes impact statement. So it's really an and, it's not getting rid of the intellectual merit, but it's adding to that very specific statement and elevating it to the importance of the grant, including how software materials, samples, data, and products will have scientific and societal value and will be shared using leading practices. And then obviously we need to fund the data infrastructure as either as part of data management plans or in an integrated way. There's another conference going on today, the kickoff of International Data Week, and a number of keynote speakers arguing there that adding, 4 or 5% kind of to the grants dedicated to data management would go a long way. We are not supporting the data management infrastructure in the way we've supported computing and, say, internet infrastructure, and the importance of that. Institutions and domain repositories really should work together. One thing that publishers have done, and we've helped lead an effort among publishers, was to try to move, at least in the Earth and Space Sciences, away from supplemental data and supplemental materials, which have no metadata and are not very searchable, into repositories, and strongly encourage institutions and domain repositories to work together. This is because, at least in publishing and I'm sure in the Earth and Space Sciences, but in most of the other sciences, most of the research collaborations now are multi-institutional or even multinational. About 50% of the papers submitted to the AGU journals come from author teams in multiple countries. The domain repositories have the domain expertise to help ensure quality metadata, and so forth. So I think there's a big win there in that many of the domain repositories have expertise but lack support. Many of the institutional repositories have support or collectively could have support, but lack some of the dedicated domain expertise. And Roger mentioned several. Here's a couple other examples of, IRIS is the main worldwide seismological repository. It's supported by a number of institutions right now. UNAVCO is the main repository, at least in the US, that supports the GPS system and geodetic repository. So there are several examples. Again, both of those are supported by multi-institutional. CERN as a physics repository in particular, not Zenodo, has an example of one in Europe. Finally, also society, the larger, essentially all the stakeholders really do work on this reward and award system. So including open science, open data, and outreach and awards. For example, the Geochemical Society did this a couple of years ago. AGU just added text to our fellows process. That will apply to the 2022 class, where nominees are expected to have shown leadership in promulgating AGU values, specifically, but not limited to, fostering equity, integrity, and diversity in open science, mentoring, and public engagement and communication. This is, again, an and. We're not taking away from the primary research role, but expecting nominees to also have showed some leadership in some other things that are clearly important. And so collectively, this is probably the largest challenge, is addressing the culture, but it's something that we all need to work together on, and happy to have a dialogue with UCLA and other institutions on thinking about how collectively the award system and reward system can be addressed. So thank you. Those are some high-level thoughts. I will say Chris and Shelley, a little bit later, we'll go into a little bit more of the fine-tooth detail on fair data and publications and repositories in particular, both on data and softwares. So thanks, and look forward to the discussion and further presentations.
Thanks, Brooke. Let's take a moment to pause, and if there are any questions that anybody has for our first two speakers, Roger and Brooks, please go ahead. You can raise your hand, and I can let you speak audibly, or you can chat. You can pop it into the chat, and we can ask questions that way. But one question I had is, just listening, Roger, I wondered if you'd like to respond to anything Brooks brought up or mentioned in his slides.
No, even though we did not collaborate or share each other's talking points, I don't think there was a single point that he brought up that I don't agree with.
Excellent. Any other
Wait,
questions?
I was nervous, Roger.
Any other questions attendees or panelists have?
Great. It's just, I think, a note from George on LIGO, which Roger mentioned.
That's cool. So, all right. So if there are no more other questions, and don't be shy, we're here to have a conversation. Let's segue to the presentation by the UCLA Library and the Library Data Science Center, and it's going to be regarding data publishing, training, and the support services we provide in the library. Todd mentioned earlier, but I'll say it because I wasn't recording. Then Wynn Tranfill is going to speak. She's our science and engineering support and services librarian. Lee Fan from the Data Science Center is going to talk about the training and software services that the Data Science Center provides. And Jamie James is going to talk about data publishing with UCLA Dataverse, which is a local repository we run. And with that, I'll hand it off to Wynn. Wynn?
Great. Thank you so much, Tim. And thank you, Dr. Wakamoto and Dr. Hansen for laying the groundwork for this talk so eloquently. Yes, I'm the Physical and Basic Sciences librarian at UCLA, and I'm going to introduce you to the Geology Library and Science and Engineering Library at UCLA, kind of bring it back to us. So the UCLA Science and Engineering Library Geology location is a fairly analog, old school type library location filled with a lot of physical materials. The department has a separate GIS lab and research lab that's run with the support of departmental IT. So shout out to Rod O'Connor, who's the EPSS or Earth Planetary and Space Sciences IT director. Great. Consultations for data management or just research in general are typically like virtual, or I visit the lab of a particular faculty member, instructor, or student who has questions about data or research, what have you. And I also want to thank Dr. Wakamoto for bringing up just open access publishing in general. Last summer, I worked on a project with Sam Teplitsky, who's the open science librarian at UC Berkeley, Mia Warren and Philip White at Houston and CU Boulder, respectively. And it was a large project, but one of our questions was, at what rate do earth science researchers read and publish in open access journals? So I just want to show you what results we have from UCLA specifically. And about 44% of articles published in the last 10 years were published open access at some level at UCLA, which isn't bad. It's pretty impressive, frankly. And over time, if we look at it, the rate of open access publishing has actually been increasing at UCLA in line with UC Senate open access policy, NSF public access policy, and then the UC presidential open access policy. So there are a lot of players that are working to make open access more attractive and available to researchers, and EPSS is responding. And as far as citing open access research, about 37% of the references that we could identify were open access to begin with when they were cited. So back to data, the types of data within the EPSS department at UCLA are highly variable. There's geospatial data, weather sensor data, Earth planetary celestial images data that we get from telescopes, and spectra data in many, many different formats. And it's separated into internal data management, within the lab. How do we store, how do we archive, how do we exchange information with our collaborators, whether they be at UCLA or increasingly beyond across the globe. And also external. So once we publish, how do we share, how do we meet our grant requirements for making our data publicly available. And internally, there's, of course, the UCLA Dataverse, which I think Jamie will be talking about in greater detail. But the researchers I speak with use either GitHub Box, which is an internally funded data storage manager, or just Google Drive. That's what the landscape looks like within UCLA's EPSS department. And externally, you can still share with Dataverse, even though most researchers I know who use Dataverse do use it internally. Zenodo is very popular, as is Triad. And there's also domain specific data repositories that are used from time to time, but often used to pull data from. Services we provide in the data sphere, data management plan consultations, mostly helping researchers meet NSF, NASA, or USGS grant requirements. We connect users to services across campus, including the UCLA Data Sciences Center, which you will hear more from momentarily, and departmental IT, which can help with arrangements for internal data storage where the need arises. All right. Passing it off to Lee.
All right, thanks, Gwen. Hi, everyone. My name is Lee Fan, and I'm the data science facilitator at the Library Data Science Center. And as Gwen just mentioned, in addition to the science and engineering and geology libraries, UCLA Library has a network of teams to support researchers' goals across campus. So now I'll give you an overview of the Data Science Center services and resources. So the Data Science Center is located in Young Research Library, also known as YRL, on the second floor. We have a suite of services and ways that we support researchers, including data and coding support. We can help you find data sources from social sciences to STEM. We're supporting campus, the campus interdepartmentally. We also provide GIS or geospatial services, machine learning and AI. We have a makerspace called the Lux Lab, which includes 3D printing, 3D modeling, and virtual reality. We have software and hardware that can support those. Any research or projects or experiments that you have that might need those types of tools. And also we host UCLA Dataverse, which Jamie will speak about afterwards. Next, please. So one of the main services of the DSC, Data Science Center, we also are known as a DSC, is research consulting on all phases of the research lifecycle, and particularly in the analysis phase. And this includes programming and coding support for data and computationally intensive projects. We can help you get started with programming, debugging, refactoring existing code, and testing programs. And as I mentioned before, geospatial analysis and mapping and application programming interfaces, we can get you started with that as a tool to access data. Next slide. Oh, yeah, next slide just showed the image of different tools and languages, programming languages that we can support you with, including R, Python, QGIS, which is a geospatial mapping software, Jupyter Notebooks, Git, OpenRefine for data analysis and cleaning, SQL, and that's the command line on that last one. So in addition, as part of our consulting services, we can also help researchers get started with applying machine learning and AI to their projects. We provide guidance on computing resources, cloud computing, such as AWS or Amazon Web Services, as well as high performance computing. So if you have a project and you think you might need more computing services or software, then we can help you navigate that and get you started. The Data Science Center also has a deep learning machine available for running experiments and software. And some common projects that we have helped we've assisted researchers with include data, text analysis, and natural language processing, image analysis. Yeah, we can go into more detail about the types of projects if you have more questions. Next slide. Okay, so in addition to consulting, one of our core services includes instructional workshops, and the Data Science Center is a member of the Carpentries, which is a worldwide community of volunteers who teach foundational computational coding and data science skills. The primary audience of Carpentries are researchers, staff, and information professionals with no or minimal prior programming knowledge who find themselves increasingly having to write code to conduct their work. And since 2017, through building our community of practice at UCLA, there are now 16 certified carpentries instructors throughout campus. So it's been great to grow our community and meet other professionals and researchers across campus who are interested in learning these skills and also teaching novices and early career researchers. If you have more questions about this, we can definitely go into more detail. And when we talk about certified carpentries instructors, the instructor training includes pedagogical training. So you learn how to teach other people these skills. And in that way, it helps you strengthen your foundational skills as well. Okay, so on the horizon for the DSC is an initiative called the Data Squad. And the Data Squad consists of a team of students who consult on data-related projects. And this was inspired by the chapter of Data Squad at Carleton College. And our director, Tim, has been leading the way in growing this team. We're still in the starting out like growth phase of it. And I believe we still are hiring for one final position. And you can find more information about that on the library website under student jobs. Okay, next slide. Yeah, so thank you for your attention. You can find more information about the Data Science Center at library.ucla.edu/DSC. And now I'll turn it over to Jamie, who can tell us more about UCLA Dataverse.
Hi, I'm Jamie Jameson, and I'm the collection manager for the Dataverse repository. And I'm going to just tell you a little bit about the services we offer and just how it works. Okay, next. We've talked about, why publish. There's discoverability. You want people to be able to find your research, your data, reusability and reproducibility. There's research transparency. Most people want their research to be accessible. You have data management plans, and funding often require some kind of a repository. Secure storage. You want to be able to park your data someplace where you know it's going to be taken care of and accessible. And then, lastly, we've talked about the community benefit of sharing data and research. Okay, next. So what is Dataverse? Dataverse is an open source web application. It's designed for sharing, preserving, and using research data. It originally really came out of the social sciences, so that you might see a lot of social science data, although other people do, other disciplines use it. It enables research data and projects to be publicly available, discoverable. It provides DOIs, both on the data set and on the file level. And it makes your data reusable. Where it came from, it was developed by the Harvard Institute for Quantitative Social Sciences, IQSS, and since then it's continues to be a very robust product. It's supported by an international team of developers, and they regularly have calls every bi-weekly with developers and the users. So we can ask the people who are users like myself. We can ask questions, get assistance. So it is a very stable product. Okay, next. Now I talked about the DOIs. You can see over here. This is just a screenshot of somebody's research project. There's both the when you publish a data set, the DOI is built into it. So it generates a citation with the DOI, and the same thing for the files. So this particular researcher, he could write an article, he could cite the entire data set. There's also the possibility to cite the individual data set or the individual file. Okay, next please. and who can use the Dataverse repository? This is for you, the UCLA community. There can be affiliated users, faculty, staff, students, researchers, research groups, centers, schools. On the left side is, again, it's an individual researcher. That's his own data. This is his own repository where he can set permissions. He can take care of his data himself. He has a lot of control over it. On the right is a Dataverse for the UCLA Mechanical and Engineering. They have a departmental Dataverse and they administer that. So this is available for everybody, and you would log in, say, I'll go over this, but you can access that, you can log in and create something with your UCLA ID. Okay, next one, please. So the Dataverse and the Data Science Center, what do we offer? We offer secure storage, a secure place to park your data with Dataverse. We've had the DOI, we have DOIs are available. There's either curation or self-deposit. Now, a lot of the older data, like the Social Science Data Archive, which is on Dataverse, a lot of that was curated because, again, it, like myself, goes back to the mainframe era, where self-publishing would be somebody coming up to the counter and handing me their tape. So the nature of how people are able to use their research has changed. Today, I'd say self-depositing would be the majority of the things we get. People like to be able to deposit their data and set up their metadata. However, we are always there to help. I think Wynn showed the White Dwarf repository. She actually helped them get started, and they're one of our first self-depositors. Now, your data, once you get it into a Dataverse, it can be either public or restricted, meaning anyone can download it, or people can, it's restricted in that people have to ask your permission, the person who owns the data have to ask permission to download or access the data. We have metrics that show the how many views and downloads for each data set, both on the data set level, and if you look at the individual file, you can see how many times have people downloaded or viewed this. The big thing we can offer is long-term usability. Within our Dataverse, we have research produced, say, the 1950s, the 70s, 80s, and 90s that is still available, shareable, and usable. And one of my favorite examples for this is the Detroit area traffic study in 1953. Dr. Carroll did this, not at UCLA, but he did this study. He published a book. Now, people still sometimes come and use that particular data because it's the original data. It's been digitized. We actually even have some scans of the cards. If not, people aren't familiar, that's how you would have loaded your data. So they can actually rerun his analysis. They can make their own analysis, and it is still usable today. Another good example is we have the survey data that was produced by the Survey Research Center at UCLA, which doesn't exist. However, the data is still there. It was very strongly an SPSS shop. So we both have the original setups as they would have been at that time, and the newer files, which you could run if you have SPSS on your available, you could run it there. We also keep the raw data and setups. The idea is we want to have enough information that you could take a data set, you can run it, analyze it, even if none of us are here. Our mission idea is to make sure this material that people have left with us will be available into the future. And oh yes, someone said original SPSS. Yes, we even have the original SPS with the JCL, or the job control language, which was used in the ancient world. Now, I talked about how long we've been doing this, so I'm just going to go to the next slide. And I wasn't going to talk about the history, but I wanted you to see that at the Data Science Center as a repository, we've had a lot of practice. We've been custodians of people's data, caring for it and making it reusable and available for a long time. And Dataverse, as it is very helpful in that mission. And next, I'm sorry, I was probably talking way too fast, but if you have questions, we're here. Thank you.
Thank you, Jamie. Yeah, so there was some questions and talk in the chat. When there was a question about the use of Figshare, I don't know if you can answer what percentage of data cited in current publications is being lost to Figshare that George asked.
I don't have the answer, but I was going to say we tend to encourage people have your data in more than one place. You don't only have to have it with us. And some
I
of
think the question was for Wynn.
Okay.
I think from her research. I don't know if that came up.
It didn't
don't
come up
know.
in the research now.
Yeah. I'm sorry, we didn't.
Mhm.
Yeah, so yeah, we don't know the answer to that question, George. And then there was a question about speaking for open data. You're surprised the library is not more integrated with other open data repositories. And Box and Google and Drive are definitely not that. We are, I don't know, we didn't really call it out like closely. Jamie talked about a repository that is kind of open data focused. It's by default, the license is set to CC by 0. So you can have other licenses in Dataverse, but it's, you know, we do push open data in that context. Chris and Shelley are going to reference another data repository that's part of the UC system called Triad, which is open by, I think they enforce open data requirement.
Yeah, like the library, like we don't advocate for using Box or Google Drive as a way to store and share your data. That's just, you know, the reality of what's going on in the lab. That's why I mentioned it.
Yeah,
Mhm.
thank you.
You
So,
know-
yeah, so we are aligned with other open data kind of repositories. We do also support or have had memberships in the past with the Open Science Framework, OSF, which is kind of another kind of more open oriented data publishing platform. So thank you for that, drawing that out.
Somebody just asked the question, did I say we encourage researchers to deposit in more than one place? People sometimes, in lieu of, say, depositing data, say, oh, am I limited to this place? And we all say, no, you can have more than one place. That's not a bad idea. Some of our data is both in UCLA Dataverse and in ICPSR. So that is something we suggest, you know, it's okay. You can have more than one place. And I think somehow we missed one of my slides. It was a graphic of Dataverse. I guess we don't have to go back to that, but yes, if anybody asks, I tell them, no, you don't have to only come with us, and it's not a bad idea to be with, oh, sorry, I think I missed that. I was gonna say how this works is a Dataverse is a container for your data sets and files and sub-dataverses. UCLA Dataverse is considered the root bucket for the whole thing, with different sub-dataverses inside. Like the one in the middle is the White Dwarf Project. That is the astronomy department's Dataverse. They have they are able to control access, publishing. You know, the individual who owns it, they have control over it. That's why I think a lot of researchers like to create their own, because they can control permissions and different aspects of publishing. And thank you. I'm sorry, I don't know how I missed that one, but I just wanted you to see how, kind of conceptually, how it works. Sorry.
Any other questions before we move on? All right. Yeah, Chris and Shelley, take it away.
Thank you, Tim. What a great opportunity. Can you guys hear me okay? I hope so. Okay. Somebody say something if you can't hear me. So kind of going back, oh, I see. Okay. Kind of going back to what was just asked, you know, data in different places, and, you know, what about Box, and how's that different than Triad? And oh my gosh, there's so many different places. So give me a moment, and I want to tease that out, because I think being really clear about the evolution that our data takes throughout a research life cycle is incredibly important. And we use these different places for different reasons, and they have different characteristics. But first and foremost, this opportunity to present with you today is so important in building our relationship with UCLA, and as well as, you know, any other institution, especially if you're on this particular call, or maybe you watch the recording later, just trying to connect to the incredible work happening at the library, happening at the institutions, the research offices, and connecting that all the way through to your society and potentially the publication platform that your researchers are going to choose. And knowing that we all need to coordinate. So a lot of the questions that Chris and I get at AGU, Chris Erdman and I, we're colleagues within data leadership at AGU. The questions we get are, I have no idea what you mean by your data policy. What do you mean preserve your data? We really need to partner with you because we would much rather they be clear on that earlier, because by the time they get to publication, it's hard. This is the last thing on their mind. They just want to get their paper published, and doing something with their data was just not even in the cards. So we really value this opportunity to connect to the incredible services you're providing, and making sure that especially folks that are coming through UCLA, and then of course all of the institutions, are doing something similar. So just delighted to see the services being provided. So next slide. So I'm repeating the slide that Brooks had shared on AGU's position statement. Earth and space and environmental science data are all a world heritage. It really matters to us. We make decisions at AGU and in concert with our partners because we know the data is incredibly valuable. It needs to be preserved. It needs to be well documented. And the folks that have created it need to get the credit for it that they deserve. And so we're going to talk about what that means in practice and get rather specific, and then give you resources when it's time for you to be thinking about this more seriously. We realize it may not be today, but it might be tomorrow. And we want you to be able to have links that you can go to really easily that dovetail into everything that's coming through from the folks at UCLA and what that means to be in collaboration with each other. Next slide. So we'll go over what it means for publication. We just want to touch on models and simulation because they're really different. We have a number of new resources and a blog area that, thanks to Chris, he's been really helpful in communication, and he'll walk through all of those. And then an upcoming large effort that's happening at fall meeting. Next slide. So brand new updated data and sharing guidance. So we have everything connected into this. And Chris, I know you're going to grab that link and put it in the chat for me, just so everybody has it. But we have everything connected. Oh, he's sharing his slide. He's probably saying, no, Shelly, I'm sharing the slides. Don't do that. Okay, we'll get you the link in a second. As soon as he starts talking, I'll do that. I gotcha. Sorry. We have it all connected here. So if you forget, you can definitely go to AGU's author guidance, and it's all here. And we're going to give you a couple other links as well. So now let me do a little deep dive on our thinking. So next slide. So you are, yep, there we go. Everyone's been talking, Brooks and I don't know if you're on auto forward, Chris, maybe you are. So trying to stick here to the parachuting person and the young fellow who's trying to find his first GIS location using this map, which is probably not the best way to do it. But we really want researchers who are taking a look at your published research or maybe a preprint to really understand what's happening within your work, building on the research that's come ahead of you, knowing that the challenges in our universe, in our Earth systems, only become more complicated. It doesn't get easier; it gets harder. And the better we can give real transparency. One of the words we use sometimes is reproducibility, and certainly that's a valuable word as well, but we tend to talk about walking towards reproducibility. That's a really big ask. So the elements that go into open science, the elements go into transparency, the elements that go into reproducibility, this is really what we're trying to share with our with our researchers, with our community. And I know you are doing that as well. So just saying, hey, I think the data is down there somewhere in this valley, go find it, is a completely different experience than here's the map, here's the links to the data, here's the links to the software, and we're going to make it really easy. So we want to give a map within the publication, within the way we link, have linking that takes place between your ORCID, for instance, or your CV to your data, to your software, to your publication, to your teams, to your affiliation, to your organization, et cetera. It's all of these connections really, really matter. Next slide. So nitty gritty, when it comes to the data and software that supports your research, there's two things that matter. One is that you describe it well, and the second is that you cite it. Here's a big important clue. Not all data is going to have a good citation because you can't control everything that's happened before you. But all data and software can be described. So not all data and software can be cited, but all data and software can be described. We want you to do both as many times as you can, as much as you can, but we realize there's a reality here. So the data and software are described in what we call an availability statement. Journals put this in different places. AGU just recently moved ours. We had it in the acknowledgement statement, and now it's in a section called open research. Just heads up on that, we moved it. The new templates all have it in open research. That's what it means. That's the availability statement. And you describe everything that supports your research. And we'll get into what everything means. And then for that data and software where you can manage a URL, preferably a persistent identifier. That's where some of the comments in the chat have been. Some things are actually preservation repositories. Some things are just good for working with your team. So I'll dig into that a little more as we go forward. You want a preservation repository when you get to publication. Cite it. You can't cite Box. Box is not a preservation repository. GitHub is not a preservation repository. As much as we love it dearly, it is not a preservation repository. So this is where we need to think about where we work on a team, which is also very important. And UCLA has fantastic resources there. And then where we preserve our research, which is a snapshot in time. Okay, next slide. All right, so describing and citing, what are we talking about? Which data, what software? So here it is in general terms, knowing that for your discipline, you're going to look at things a little differently. Data used from others. So you want to give credit. If you're using somebody else's data, you want to give credit as best you can. Any data that you've created for this particular research, you want to also describe and cite it. And that gives you credit. Remember, data is a separate research product. So to connect between your data and your publication, you have to include it. So I know sometimes that's a mind blow, but Shelley, it was part of what I did for my research. I don't cite that. Oh, yeah, you do. Yeah, you do, because you want to connect that data to your publication. Really big point here. And then anything that you aggregate, any derived data product where you've put together, five data sets or something. And yeah, George, I see your note. So hang tight, we'll get to your note. Whenever you're putting something that you've analyzed, something that supports your visualizations, something that your research findings are dependent upon, this is really important for you to actually cite that's derived data product as well. And then for your software, there's a lengthy conversations happening on, okay, do I cite Word? No, you don't, please don't. This is software that supports your research, and this is probably worthy within your discipline to have a discussion. I'm gonna hold on the discussion here, and we can point you to additional resources where there's a bit of a deep dive into, okay, which, is this better than that? And we can walk you through how to think through the best software to be cited. If your outcomes heavily depend on research software, you're going to want to cite it. That's the general statement. Next slide. Okay, what's an availability statement? So what Chris built this. This is a great slide. And we like to call it the anatomy of an availability statement. So maybe Chris, we need like, I don't know, some anatomy lesson going on here, but I'm sure we'll do it wrong. So it's probably good that it says it the way it does. So at the top, you're going to want to describe the data or your software. For AGU, you have to include your data. Software, we have a little bit more wiggle room there. It's not as mandatory as data is, but some journals it is. For instance, our modeling journal, James, yes, you have to include your software because the outcomes are primarily based on software. Where is it? So this is the repository. This is where preservation takes place. This is not Box. This is not a general website someplace. This is an actual preservation repository. Zenodo is one of those. Triad is one of those. Dataverse can be that. And if UCLA can just weigh in that you consider your Dataverse a preservation repository, I think so, but please confirm. And then include a URL. We want that persistent ID from the preservation repository. But here's the thing, if you don't own that data and it happens to be sitting on a website, you don't ethically have the ability to preserve somebody else's data. So you have to do the best you can with somebody else's stuff. And we actually have some guidance that Chris and I have written on that. So remember, if you don't own it, you can't just do whatever you want with it. You have to actually identify it as close to it, where it is the best version that you can. And then access conditions. Do you need to, for instance, register to get access to it? And these can get even more complicated. Sometimes you have to go through IRB. Sometimes you have to, this might be satellite imagery that you have to pay a fee for. So you need to be really clear on what those access requirements are. And then what's the licensing? Is this, because really key point here is you can't reuse somebody else's data or software without having been given the usage criteria. And this is where licensing comes in. So the usage criteria is really important. So for data that's commonly Creative Commons, for software, software has different requirements. So there's usually other licensing that's recommended. And our website has more links to these resources. And then get yourself, if you could get a citation, because you had all the elements to create a citation, then yes, go ahead and put your in-text citation here. So that's why it says where possible. And then for software, also include in your availability statement the version that you're using, because the version matters. And then if you do have a GitHub site that you would like to share for the most current work that you're doing, this is the appropriate place to do that. Put your GitHub site here. But that's secondary to the preservation. Next slide. So we're gonna walk an example. Now, this is WRR. So our water and hydrology papers tend to go here, and this is about freshwater mussels. So you've got a link. We had been moving to our new data policy as of 2018. So that's why this is a really great paper. We're continuing to improve our policies. So we continue to have more papers that are good examples, but we're going to use this one. Next slide. So this is the availability statement for the paper. Now, remember I said to you that AGU's just recently moved from having those statements in the acknowledgement section, now in the open research section. So here's one, because this was a couple years ago, where the availability statement was an acknowledgement. So that makes sense, right? Because this looks like an acknowledgement statement. But it very clearly is tacked on the bottom. We could have easily lifted this and plopped it over into the open research section, but it's here. And it's great. It's fantastic. It's very nice. It's got the repository. We've got the DOI. And because it has a really nice landing page where that data is, although there were several other elements that could have been included here. For instance, they could have said, what the licensing was. They could have said, This is openly available through Creative Commons something. We do know that this particular repository is very good about tracking all of that as well. So it is identified nicely within that repository. So it does not necessarily have every single attribute, but it is accounted for that data set. Next slide. So here is in the reference section what it looks like, where the actual citation is located. And this is very nicely done. I'm very pleased with this. And there's a nice link to the DOI is there. And the DOI to the paper is also identified there. I think that's what that is. Now that I'm looking at it, yes, I think that's correct. Next slide. So here is the data set in the Triad repository. And we have the creators of the data above. They don't necessarily have to match the writers of the paper. Just in case, if you have a large team, you might have folks identified with different contributions. We've got the persistent identifier that you need to have to create a citation at the very top, followed by I love this. This is an incredibly helpful recommendation for the citation. And then Chris is going to show you a tool to make this even easier to align with your journal style requirements. And then a description of the data there at the bottom, which is the abstract. And there we go. Okay, now let's talk about credit. So we have an availability statement. Journals can put them anywhere in their paper. AGU has theirs in the open research section right now. And we have a citation in the reference section. And we have it there because that's where journals create credit from. That's where the linking takes place and the automated credit and attribution happens. It's just how our systems work. It's rather legacy. Feel free to roll your eyes if you would prefer a different way, but this is where we do it. This is where our journal does it. And this is true no matter what your discipline. So following the journals have their own criteria. There's certain standards that we align to that are managed through NISO. And this is it. This is where anything that's supporting your research is when you create credit, this is where it happens. And the reason there's a couple of reasons why it's here. So let's see, I covered the first one, citation, getting you credit. It's also important to be able to have automated credit because you want to be able to list this in any promotion and tenure packaging. And then for like societies such as AGU and other societies, we are updating our honors and awards to recognize contributions of well-documented valuable data sets to our community and software. So this matters to us. So we've actually, our Committee for Honors and Rewards has made adjustments to lift the value of data and software. And this is in the process of happening right now. Maybe Brooks will put in the chat if he's still here. Yes, he is. When that takes effect, but they've just approved it. And we're really excited because it really demonstrates how important this is to AGU. There it goes, next year. It's going to go into effect next year. So tell folks that you really want to make sure these things are listed and that complying with all of these requirements and participating in open science in a way where your data and software are reusable matters, especially matters to AGU. And then funders have updated what they are allowing for costs to include data management costs and long-term preservation. And we're delighted with this. NIH has made a huge statement, and we know there's work happening at OSTP and some really huge work happening at NASA, as well as USGS. Things that I happen to know about that may not be really in the news just yet, but I know NOAA's working on this, as well as other federal agencies. So this is really very helpful. Next slide. So what does it mean for when you cite your data? So what this means here is as your paper's coming through peer review and after being published, it's much easier to evaluate your research. So much easier that our editors don't like to actually accept a paper unless that data is cited openly. So just be aware that through the COPTAS, Coalition on Publishing Data in the Earth and Space Sciences, most Earth and Space Science publishers require that your data be cited in a community acceptable trusted repository, preservation repository, where the citation can happen. So especially within our domain, that is a big deal. We want that data to be support the data that supports the research to be available. And so it matters. And it also allows your work to be discovered in other ways. So if you're hunting, if a researcher, and think cross-domain, where it's harder to find relevant research in a different domain area, but the data might be useful, you may find someone who's hunting for certain types of data, and they come across your research through the data set or through the software. So you're able to be discovered in different ways. And through linking, you can also, the concepts around knowledge graphs and PID graphs, this is also a really exciting way to make yourself more visible and discoverable, because you are connected to your data, you're connected to your software, you're connected to your research, you're connected to your affiliation. And then these graphs, these hubs and spokes can all be navigated digitally, and you can be discovered in other ways. And then, oops, I just covered that. So preservation for the scientific record. So making sure that your data and software that went into your research is preserved as its own research product, as well as your paper is, and that linkage takes place. And we just talked about that. The supplemental information is not linked in a way that's helpful. You can't find the data there separately from the paper. You'll always have to go through the research, which if you're just working in a small group, that doesn't really matter. But if you're working, the trajectory right now is most papers are going to be collaborations internationally, less papers, the teams are in one country. So finding and connecting to people is going to be even more important as your research, the complexity of research takes place, and we're recognizing worldwide systems. Next slide. And by the way, I have a reference for that. If somebody wants to see the reference for that, I do have one. We do have research showing that if you cite data, although this particular reference does not have software, I will assert software here, but if you cite your data, that you have a higher potential of your publication being cited as well. So the folks at PLOS did some analysis that is very promising. So that's really helpful. Next slide. Okay, this is a recap. So getting credit for your software data, either from your team, from your research team, something you're contributing yourself, there's two things: get it into a trusted repository, preservation repository that supports citation, and get it into the references section of your paper. Remember, you also have to identify that in your availability statement as well. All right, I think I'm handing to Chris.
Yeah, thanks, Shelley. And
all right, take it away.
Sorry for the skipping earlier. I tried to respond to all the questions in chat. That's why it was skipping. So I decided not to, and we have 12 messages in there now waiting for you. Yeah, to start, I'd like to start off with actually something that Shelley mentioned earlier. One thing that we found useful is this tool from actually cross-site from DataCite that helps authors sort of with putting together their data or software citation. So you can see an example here, and we found this is extremely useful. Had many exclamation marks from authors regarding this service, and actually it's really nice example to show something else that Shelley mentioned. There are changes happening at this moment with how we cite data and software. You can see something that's in this bracketed description. So data set. This is something we're working on right now, and it's part of a project with and I think this was mentioned earlier. It takes a village to really make change in the entire system for us to support data and software citations. So we're working with a village to really help with that moving forward. And so that the data and software citations, not only that, but so notebooks like Jupyter notebooks are actually registered, they're indexed, they're credited in the system. So, but this is a nice example that we point to from the page that we mentioned before. So Shelley and I really worked with Brooks and other people at AGU to wrap up these resources for authors in one, really one place that can help them find all the information that they're looking for. And we've gotten a lot of great responses for this to help people sort of find answers to the questions that they're asking. It's evolving. Of course, we're working on this. And I think that's what we'll speak to next here, is that one of the things that we're spending a lot of time on is working with the journals, specifically on what Shelley referenced earlier too, is sort of the looking at the domains and what data and software really means to them. And in that process, actually, it was really great to work with all these journals to understand what it means for them and their examples. So you can see some of the journal specific guidance that we have from JGR planets to tectonics. But in that process, we started working on sort of a common shared guidance that really makes it easier for all of us to in AGU journals to be on the same page. And what's great about this is that all the journals sort of feel the same about the guidance that we're moving forward. So some of the differences that we're moving forward in our common guidance is that software is being stressed more. We also provided clear guidance to models. And also another thing to just mention here is that one of our editors actually passed away, and so Peter Fox really sort of sparked this, and we built off of that. It really inspired us to move forward. And you can see also these two examples to the right, where we're also moving to a transparent way of working. So it's hosted, this guidance is hosted on GitHub. It's also in a release mechanism, so we can actually release it and get DOIs and cite it as well. So we can cite specific release versions and work with the community that way. And I mentioned, like that in those conversations with the journals, this is one particular place where, it was great working with community members. The NCAR, a group at NCAR, as you can see here, was working on best practices for preservation and I can't say it, replicability of model data. That's a hard one. Third time's the charm. Where they developed a rubric of how to work. And we heard it earlier. It's very hard to understand the sort of underlying questions of what do you preserve? And we incorporated that into our latest guidance. Again, it's iterative, we're improving, but it was helpful to have this guidance from this group, and I recommend looking at that. And that's just an example in general of where we're headed in data.agu.org, where we have these resources, where we work with community members, or we share what we've learned working with community members of how to share or how to think about particular aspects. And so you see here one example that I'll actually talk about here is digital presence. And this is really an important point to make. Again, Shelley mentioned that in the Beatles slide earlier on, we get by a little help from our friends. We really get by from your help, from the institutional perspective of the work you do with authors on working with them on understanding what they can do with ORCID, what they can do is sort of managing their digital presence. And in our sort of exchanges with authors and with our members from institutions and other places, is this digital presence resource where it really helps authors sort of walk through how do they link all their activity, so papers, data, and software and other research objects into their digital presence, their ORCID. So this is a really nice resource from all that we've learned from working with all of you. And another one is the software citation. So this is work that we did sort of also in the same vein of listening to our authors, working with them, understanding that we need to be sort of quick and thorough about here are the top 5 things you should know about when you're working with your software. And again, this points back to working with the community, working with an institution. So software management plan, we've mentioned data management plans, that planning that happens early, especially choosing a repository is so instrumental for helping us downstream. And so this is, again, a resource that we put together for working with our community members on data.agu.org. And then another one that's exciting, and we started off with this broad scope of, well, we want to work with sort of executable research containers and other parts of that executable package. And that's a tricky space to work in. And so we decided to scope initially to something that we hear a lot about in AGU is I want to publish with my notebook. I at least want to cite it, or I actually do want to publish a paper, from a notebook in an AGU journal. And so we worked on this guidance with again, community members. I think it's roughly 10 to 15 people to get their feedback and incorporate into hopefully a streamlined resource that can help walk an author through publishing their notebook, citing it. Again, we're expanding the work we're doing in data.agu.org, working with everyone. So if you're interested in working with us, that's great. If you have ideas or topics, please let us know. That would be great. You can reach us at datahelp@agu.org. And I think we have a slide for that later. But here's just an example of some of the recent posts that in some ways, like the first one, we felt no one was really talking about. We talk about in these sessions and we don't know necessarily how to deal with very large data, but we have to deal with it on a daily basis in AGU data leadership. We get these questions, these challenging questions of what do I exactly preserve? Is it all the data or is it some of it? What particular aspects? And so we decided to put it out there and get feedback on it and iterate of course again and improve. And the other thing is this digital presence. So we found that it still wasn't clear where you could find some of those resources about auto updating your ORCID identifier with data software papers. And so we decided to write a post on that. Actually, Shelley's fountain of knowledge, and so she led that particular post. It seems like I'm changing here. I was a little stalled, but I think one of the last points to make here is we've been doing this for quite some time. As you see, data fair and software. We've been doing this event at fall meetings. We work with a number of colleagues, particularly with ESIP, that sort of helps manage the data help desk. But we also work with EGU. We work with others in managing this help desk where people can tweet or they can send us emails, or we can see them at events. They can ask their questions at events where we help them sort of respond and ask some of the difficult questions that they have. The other reason why we point to this slide is that it's very much in our vision that we see working with the community as important. Shouldn't just necessarily be a data help at AGU where we get these questions. We want to work with community members on providing that guidance, that feedback. And so this is an important slide, important point for us to say that as well. We definitely see that in our future of expanding those capabilities. And I think this is again coming back to the Beatles theme, which I really love. Shelley brought up this important Beatles quote, but with a little help from our friends. Again, this is why we're doing this session. We really value the work with community members, especially from you heard from the library and our institutional members of like how we can better prepare our authors when it comes time to publication for responding to all these sort of questions and challenges. So, and again, you can reach us at datahelp@agu.org. That's available to our authors too. They send a lot of questions, challenging questions that we have to respond to as well and help them with their data and software needs. And so you can also reach Shelley and I at that email address. So thank you. And it seems like the chat has been really active. It's almost 30 chat. So I'll stop sharing.
Thank you, Chris. Do we want to actually talk about some of the questions that came up in the chat? I know they were answered in the chat, but we might want to talk a little more about them. Somebody was asking about how to basically publish your code. And I don't know if you want to talk about the integration with GitHub and some other platforms out there to kind of make your code executable in kind of a cloud environment or capture your software environment so it's runnable. So you might want to jump in with that. I think Brooks answered some of it and Shelley did as well. So go ahead, please.
I'd really like to talk more because this is an area that Chris and I have been working really hard in. We're really seeing these combined platforms, notebooks, and full reproducible platforms like being an important element going forward, but there's a number of challenges with them. So first, starting with like a basic concept, we love GitHub, but again, it's not a preservation platform. There is a fantastic bridge that actually Chris helped when it was first implemented to go to Zenodo. There's a little tiny bit of a kludge to it. You have to check your metadata on the other side, add the ORCIDs. So you need a login for GitHub, which you would because that's where your software is, and you need a login on Zenodo. You use the bridge to push over the available metadata, and then make sure the title's right, make sure your ORCIDs are right, and just check the rest of your metadata so that it's a really strong citation, and you can get you can do version control that way. And there's also a new .cff file that you can add in to help you build that citation. So look for, of course, I don't know if you have that link handy. I can find it in a second, but there's a brand new integration with the citation.cff file that will help you there. So you can be cutting edge and, the first on your block to implement citation.cff. The software folks are very excited. So, but that doesn't get you reproducibility. It might, depending on how you set up your GitHub, but it might not. So we do have these other platforms. And actually, Chris is probably a little bit more learned here, but we're, MyBinder and Wholetail and Docker, they all kind of work together, and then CodeOcean. There isn't a way, not all of them are at the same level of transparency. So you have to realize that. Some of them have fees either for the publisher or somewhere embedded. Some of them are not well funded for long-term preservation. And then some of them look really fantastic, but we're not 100% sure. There needs to be some discussion yet. So there's a lot of great stuff. Yep, Chris is going to talk. And then how to cite everything in the package. How do you get credit to the data when you just cited the package? So we're actually Caroline Coward is in the attendee list, and she's helping me with a project to try to figure that out too. So we'll know more about that hopefully soon. Go ahead, Chris.
Oh, it's really short. I think this is where I think a lot of the work in and often referred to as fair workflows, where I think people like Carol Goebel, or there's actually in California there's a group at Santa Cruz that works on NIH projects called DocStore, where they look at sort of these fair workflows and how you can sort of publish your environments. And a lot of this work, I think, there's a lot of work on in sort of the NIH funded land biosciences, and it would be great. I think that we're starting to see that, and on the geosciences side, and I think definitely in Go Fair US, which I'm part of the team there. We're looking at trying to support community calls on how we go about making your workflows more fair, because it is a challenge. We see people using multiple high performance computing environments, and data is in one place, a model might, pipelines can be in another place. And so, I think really, I feel like what could help us there is having people think about fair workflows and how you can share between these different resources the work that you're doing. So more to come, but there are some interesting projects there, like Workflow Hub, which is EU project, and Dockster.org, I think. So.
Thanks. Yeah, and if there's any other questions, please just go ahead and put them into the chat. There's also somebody brought up AGU's policy aligning with COPE authorship contributorship. And I think Brooks might have answered some of that, but if anybody else can join in, Shelley, Brooks.
So yeah, I'll just expand on that. So obviously for paper authors, we expect authors for our journals to comply with COPE and our authorship policies. In addition, we have implemented credit at least as an option across, it's a requirement in some journals and an option across other journals, but strongly encourage it. For the repositories, repositories have, I guess, a varying understanding of publication authorship policies, and strongly encourage. Some follow the journal policies closely and COPE policies closely. There's been an effort at Force 11 to provide, it's really data ethics, and in the same way that COPE has had publication ethics. So things like a journal, a question is raised at related to a data set that a journal is published, how do the publisher and the repository work together to resolve whether it's an authorship dispute. As Shelley mentioned, they could have slightly different or completely different or vastly different authorships, even if they're in the same author group. So if for example, someone says, oh, I should have been an author of the data set and the paper, how do the repository and the journal work together with the institution to resolve that? COPE is now part of that, and COPE has helped, will be kind of integrating that into their guidelines. But that's hot off the presses, and hopefully it's actually just been finalized in the last month or so. So that kind of collaboration should be coming forward, and enrichment on what COPE is offering. But the authorship policies for a data set that is going to the repository actually follow or should follow the policies of the repository. Hopefully that gets standardized and most everyone will use credit and an additional statement provided. But I think that is something we still have to work on across the kind of repository discussions.
Thank you, Brooks. So Brooke, why don't you, we've mentioned Force 11 a few times. I don't know if everybody on the call knows what that group is and why it might be important for this audience.
So that was a group that was, I guess, founded in 2011 and has been kept going to deal with broadly data standards and repository and publishing standards, but more on the data software and technology end in support of science.
Thank you. Another question that came up was about the Web of Science, including acknowledgement statements. And then the question is like, how are other of these database providers or data providers doing in this area? And what is AGU doing to kind of facilitate that for our work with these vendors.
Shelley, do you want to take that? I know you've been working with Clarivet specifically on that.
Yeah. So there's a couple angles that we're looking at there. Indexers are just starting to take data citation more seriously, Web of Science being one of them. Software is they're just starting to think about software. And they don't limit themselves to just the citations. So they do look in a variety of locations. I did talk to them about how that works. As a matter of fact, they do even look a little bit beyond the acknowledgements. But one of the nice things is if you follow what I said today and what Chris has indicated and what Roger has noted, and you get your data and software cited in the reference section, all of that starts to become automated and actually can help populate the linkages. And you don't end up having to deal with a manual process that the indexers are doing. And they can then, I'm sure they'll further enhance that, but that will help give a much better base connecting your work to together. So one thing Chris mentioned the digital presence guidance. So the big clue on that, so you're foot stomping what he's just said, there is a series of steps that you can take that your ORCID can be automatically updated with your publications, not just papers, but also data and also software. And you only have to do it once in the lifetime of being a researcher. And it makes sure that your ORCID hub, like everything that connects to your ORCID, it's not your CV, right? Like you should connect your CV to your ORCID, but this is like a digital hub of everything that you do. This will walk you through it. So please do, if you have one homework assignment coming out, please go through the digital presence checklist and make sure that you do that so that you will get everything updated. And that will then connect it all together. And it's easier for the folks that are generating reports on your contributions to include your data and software. And that will be fantastic.
And one thing I'll add to that is many of the funding agencies, NSF and NIH in particular, are actually building researcher profiles from that ORCID list. So it actually makes it really easy for your researchers in submitting grants, because all of the information that NSF or NIH needed is simply pulled from your ORCID account, and you don't have to re-enter it. It makes it very efficient.
Trying to get my hand to go through the background here. I think we can say this too, is that I added the link at the very beginning, but there's a NASA project on open science right now. They just launched, and one of the projects there is to expand the NASA astrophysics data systems. And so, one of the projects, we have a conversation with them about how we'll be expanding, access that way through the ADS. And also, just to mention, my background is in libraries, so this is a near and dear topic, as Brooks and Shelley know, as I send multiple messages to them every day or every week. But just know there's a librarian on the staff at AGU.
Thank you. And Caroline asked, is there a link to the checklist? And Shelley provided to the digital presence checklist, and Shelley provided it. And I'll paste that into our document too. I'm trying to copy all the questions over into our shared document, Google Doc, so you can have it for later. Are there any other questions or thoughts, or anybody else want to, panelists or attendees, please populate the chat or come off mic. I wanted to call back about the GitHub to Zenodo integration. It's also excellent for, like, say you do slides in R, right? That you're presenting. that integration works really nicely, gets you a DOI. It's very smooth. So there's other formats that it doesn't just have to be your data or your, stuff related to your article. I mean, you can do a number of different formats in Zenodo. So it's a nice, smooth integration. So thumbs up for me. Right. Any other questions, thoughts? Otherwise, we could. I kind of knew we would end early, but it's always good to give back time too.
Oh, Carolyn mentioned again the data citation community of practice, and she's doing a lot of work there with Shelley and a colleague Deb Argawal. And it's really a difficult challenge. It will ultimately help me and in the data help desk in some of these questions, that Shelley and I receive, where it's really how do you sort of cite 50, 100 data sets, but it's not just data, it's other things as well. It becomes a real challenge, as we sort of start. As we progress even further into computational research. So I don't know if you want to add any, Shelley, maybe I stole your thunder.
No, if anyone's interested in it, there's a large group meeting next week on Friday. I think, Caroline, I think that's right, where we're going to walk through the use cases that have been developed in preparation for an actual recommendation to be shared to the broader community in December. Oh yeah. That website that Chris just put up, I think Chris has to. Chris, would you mind adding in the meeting next week, please? Thanks. So you can get information. Oh, there we go. Nice. Was that from Caroline? Yes, Caroline, thanks. So there, you can go ahead and register for next week, and you're welcome to come. We will make a recording, so if you can't come, just go ahead and register, and that will make sure you get a link to the recording later. The idea is we're going to figure out how to actually implement the concept around a collection DOI so that a single DOI can represent like a package for a paper. And this is meant to resolve the problem with, like, say somebody's looking at 1,000 images or 1,000 data sets, some of these larger systemic, not systemic, but like Earth systems challenges, IPCC report, for instance. Getting credit to the actual data creators that went into the findings of the IPCC report, that is very hard to do. So we have a use case for the IPCC report, some within the bioinformatics, and we're really excited about it. So that we're really close to having a recommendation that we can roll out, and this is where the indexers are going to help us out. They will index it and actually generate, go down a level within the DOI to actually get to each of the child packages. The whole kit and caboodle, right, Caroline? One persistent identifier for the whole kit and caboodle. So this goes back to that comment before about executable environments. How do you cite that? So this is, we think that this community of practice for data citation this will have a usable solution for that environment too, where you can cite the software, the data, whatever else goes into it, the workflow, configuration files, think as complex as you want, and samples. We haven't mentioned physical samples in this particular webinar, but we also within the Earth and Space Sciences are very keen on that. So you could actually include in this collection DOI all your physical samples as well.
Cool.
All right.
So Shelley and Chris and Brooks, how do people keep in touch with you, or is there like a good way to get information about these upcoming meetings and in a continuing way?
Brooks, yeah, the data help at agu.org gets straight to Chris and I. unless Chris is on vacation, you'll normally get him to answer. But if he's actually at the beach, then it's me. But yeah, that's the best way. There's also on the Coptus website, you can sign up for those broad emails for anything within the Earth and Space Sciences having to do with publishing or repositories. So that's another really great place. The community of practice, if you just register, we'll keep you in the loop on that. So that's that particular group that happens there. And then could Chris, can you put We Share Data into? We Share Data is, it has, and we tweet too, yeah. Thank you, Brooks. This is societies, not just the Earth and Space Sciences, but societies broadly talking about data sharing. And it was a 12-month, envisioned as a 12-month effort. We're coming into month 9 or so in a couple weeks. And it really links together broader concepts around data sharing. And we've had some really incredible speakers. Marcia Bicknut, the president of the National Academies, is going to be speaking in December. Challenges around the metadata associated, metadata necessary for reusability when you're using a general repository is the next meeting in November. And then we're going to have a recap session in January. But the resources are all there. Plus, they're all in our Zenodo community as well. So you can also cite those as well. Yep, and we're getting Twitter handles. And no, Brooks does not have a Twitter handle.
Question answered. All right. I've always wondered. He is on LinkedIn though. I saw him on LinkedIn.
Yes. Oh, I wasn't gonna tell. He lurks on Twitter. He doesn't actually, you can't actually write to him, but he does monitor Twitter.
Mysterioso.
I wasn't telling. Are you going to give out your handle, Brooks? I don't even know your handle.
It sounds like
You
a
can search for it, Shelley.
It's searchable. All right. A whole bunch of UCLP.
I'm glad we can bring y'all together.
Seriously.
Yes. So are there any other questions, thoughts? I think this is an auspicious kind of beginning of a nice relationship. And I think this really helps us a lot in the library and at UCLA partner with a great group like AGU to figure out how to better support researchers on campus. So, and any connection points back and forth that we can make, it will be the only benefit for all of us, I think.
We're working on a series of touch points. I wouldn't call them full-blown workshops, but touch points on open science, pointing to other larger guidance. And Chris and I have a goal of getting pretty far along by December, building those out. And you see them in the data.agu.org. Everyone that we've completed is there, but it's going to be like a journey. And so it would be really fantastic to share that with your community once we're ready to go, and just sort of make more connections through that. When Dr. Wakamoto was speaking, that really resonated from his talk, and that might be really good.
Yeah, that'd be awesome. And I kind of interested. I'm involved in some transparency and open science and social science groups. And the overlap between disciplines is kind of interesting. What are are there like some, generic practices we all can kind of focus on? So they're a more multidisciplinary approach.
Yeah, we agree.
It's exciting. So, any other questions, thoughts? If not, early lunch. That sounds good.
Thanks, everybody.
Well, thank you, AGU.
Oh,
Shelley, Chris?
Carolyn is confirming, Tim.
Oh, there are overlap.
Yep.
Cool.
Caroline is at JPL. She runs the library there at JPL. So she's a really great person to have on your include list.
Cool.
Oh,
Okay.
we well, we put in actually a proposal for open science. Caroline knows about it. So it's already begun. But also, Tim is really connected with everyone as far as carpentries goes. And so I guess it's another point to say that, again, it takes a village. So, we all want to work together. So if anyone else wants to be involved, let us know.
And with a little help from our friends.
Yeah.
I hope you guys thought that was funny.
No, it's great. I mean, Beatles are on the mind because the upcoming documentary next month. Everybody's talking. So yeah, that's great. Yeah, and thank you from the UCLA side, Wynn, Jamie, Lee, Todd, and yeah, thank you, AGU. This is great. I'll share out the document, and then this recording will go up on our YouTube account. I'll let you know when all that gets uploaded.
Great. Take care, everybody.
Thank you, everyone.
Tim and Todd,
Thanks,
thank
everyone.
you.
Take
Thanks,
care.
everybody.
Thank you. Thanks, everyone.
Thank you.
Great program.
Second stop.